So, let's start. They just told me the time is running and we don't wait for the others. So I'm happy to see you for my presentation about Buildpacks. And the idea of my presentation would be to have a deep dive into the topic so that you better understand what Buildpacks are, what Buildpacks do, and why you should actually use them in your applications. So that's the goal. That's me. I'm Patrick. I've been on stage already here, I think, for the third time or so. For the ones who know me already, I do things about Spring, like Spring Star, you know, Spring Boot, Spring Monolith, Spring whatever. And another topic I like a lot is Buildpacks, because I like to make things simpler for software developers. Because we know all that basically, like if somebody tells he or she is a full stack developer, I actually always say like that can't be the truth, because it's impossible to know everything from software development to infrastructure to testing to security and everything, and even cloud and everything like this. So my goal in general is to reduce cognitive complexity for developers so that people working in my team just can do the things right? So that's the goal. Of course, there is a lot of other complexity still, because it's the domain, the things we are building, everything which has to do with business. That's definitely always a challenge. So that's why I'm saying my focus is on software development for humans and with humans, because software development is about the interactions, and software and the tools we build they're just the tools, right? So I'm also, besides doing some work with software development teams, I also teach at the University of Applied Sciences, and I'm involved also in Switzerland in the software development community as well. So you got already the point where I said, like, I really like to reduce cognitive complexity, right? So we will have a look at the parts in the Buildpacks, and therefore, actually, we will have a look what Buildpacks really are. Then we look at Cloud Native Buildpacks, because there are like also different implementations. Then we will compare them against Dockerfiles. We'll have a look at some tooling around it. And if you have been in Andres' talks today regarding reproducible builds, Buildpack can help you with that too, to reproduce like the containers you're building. And then this is related also to the software supply chain, SBOM on the observability stuff. And then we also look at some advanced topics like what you would usually face when you do that, like in an enterprise environment, because you know all these problems, certificates, proxies, these kind of things, like all the way down. So it's always like the same thing. And then, of course, we're going to have a look at some examples. I show you some logs, because I can't run the builds. It would take here way too much time, but I've reproduced some logs, so we can look at them together and try to understand what Buildpacks do. And I show you then afterwards also some special cases as well. So, and of course, in the end, Buildpacks belong into the pipeline and not like, they should not be executed on the developer's machine, because pipeline is where we build containers. So what are Buildpacks actually? So wait a second, before we go there, I want to ask you one question first. Who is using Buildpacks? 2, okay. Who is writing Dockerfiles? Okay. I hope you get some ideas why Dockerfiles, at the end of the talk, of course, why Dockerfiles are maybe not such a good idea, and maybe you want to try something else, right? But I'm not preaching anything here. You will just see writing your Dockerfiles might have some challenges. So that's why we are here and we dive into the topic. So what are the Buildpacks actually? So before we go into the Buildpacks, we know how containers are built, right? What is in there, how they are done actually, like in the operating system with like features from Linux. And we know that the idea is basically like to isolate applications. And that's wonderful, because you can just throw away the container if you want to have a clean slate again, basically. And of course, we know also that containers are layered. We might have like some parts from the operating system at the host level. then we have like the base image, we add like the JVM, we might add the application, there is metadata, there is an entry point and things like that. So like what we know from typical containers, right? Now the build packs, they are used to actually like building those containers. And there is like a organization, well, it's actually like a CNCF project, which is called buildpacks.io, which provides a specification for how to build things with build packs. So in history, if you would have a look at the history slightly, you would probably realize the company on the left side on my drawing, it's called Heroku. Long time ago, they were isolating applications from each other and running them for us in the cloud. So they used build packs where you could actually or where they cloned the repository, they were building the application, and then they just containerized it in a way. So they started with this idea of build packs already like more than 10 years ago. Then a little bit later in history, there was this thing called Cloud Foundry, and I'm not sure like who remembers that. The famous thing was just like CF push. You pushed an application with this command on the command line to your cloud environment, and the platform was containerizing the whole thing. And there is actually that thing where we got like version 2 in the flavor A and B, which were quite similar but not still the same. And everything converged at the end because Pivotal at that time, right? Now it's VMware/Broadcom. They joined forces by specifying build packs. And now everything is basically like a specification, and many companies like also support this kind of tooling. So that's the idea. And what I like about that is we don't need Dockerfiles at all. So somehow magically, and you will learn how, the containers are built. So Paketo is just an implementation of build packs. So there are many implementations out there, but Paketo actually like is also, you could say like the reference implementation, or like also the widest adopted one, because Paketo just provides you CLI and everything around that. So build packs are not only about Java applications or like Spring applications, it's also about like containerizing Go applications, PHP applications, .NET, static files, JavaScript, or even Node, and so on. So you see the logos there. So in the end, the goal is actually to have a container built in a way, and always in a same way actually, but for different technologies with their specific needs, right? So you could imagine, for example, if we have a Spring Boot application and we find the fetch jar and we try to build with build packs a container around that, it will recognize it's a jar file. So we need to add the JVM and things like that, right? If you have a file called index.js, for example, it would recognize, and of course also like something like package.json or so, it would recognize we need a node instance installed in the container, and it will just detect that and create the containers. So that's actually like the thing, right? So by detecting certain things, the container gets, or the base image gets adjusted with the things my application needs. Sounds still like magic, and a lot of detection needs to happen behind the scenes, but we will learn today how it's done behind the scenes. And we will see even like steps, how they were detected, and also like then the things were executed. Okay, so build packs are definitely like relevant today, because like building or writing Docker files has a few flaws, I would say. Because when you Google, or maybe use ChatGPT or whatever these days, you find so many bad examples because of like security issues or the way it's done, maybe not optimized in the best way, and so on. So they have usually like some flaws, because just like the ones who wrote the blog post or like a Stack Overflow answer, they just didn't know it better. And many people are just copying that. Another huge advantage I like a lot, and that's why I think it's so nice, also like with the different technologies, you can streamline the way containers are built in your team across multiple technologies. When you use build packs, you always use the same approach to build things. So that like your Go container is basically like done the same way how your Java container would be done, right? Of course, there are different things in there, but that means like the approach is consistent. And if your team who takes care of maybe the platform, they just can like change things if there are certain vulnerabilities in the same way. You don't need to know about the specific features you were using for this or that container. Then actually also like Buildpacks are usually quite well maintained, so you get updates regarding vulnerabilities quite a lot. So what I have seen in the past was like something popped up in, for example, Ubuntu, and like 2 or 3 days later, we had a new run image for the Buildpacks, and it was already fixed. So I just can go basically like with the newest updated versions of the container. So this is something kind of like built in. Another thing I highlighted already is basically like you can use caching functionality in Buildpacks, so you can rebuild things faster, and you can also have like reproducible builds. So they are binary equivalent if you build a container twice. And that's something you want to have, right? Because then you can prove what was here, what you found on, for example, on GitHub. You can build it on your own, and you know it's the same. Or if you get it from Docker Hub, for example, or somewhere else, you really can reproduce it. This is not so easy to be done. You need really to have a special approach for that. And then, of course, because of like things updating like the run image, so like a base layer, there are like command line commands you can use just to like change the run image and not need to rebuild the application, which is like on higher layers, for example. So that's why it would smoothly fit into DevOps workflows, because you don't need the software development team to actually like fix issues which is in the run image you are using. What is also quite interesting is Buildpacks at the heart of the things is heavily adopted by many topics. So you see on the top left, like the PaaS platforms. There are platforms supporting that, of course, Heroku, but also like Google Cloud has things there, and others. The CI/CD tools, local dev tools supported. Local dev tools means, for example, like a CLI tool. There are, for example, also container registries, which show you like the layers of your containers, and they can actually like show how the layers are done. They're slightly different from like what you would do with Dockerfiles, but you could see that they are created by the Buildpacks, because it has kind of like different metadata in there. So the ecosystem adoption is quite huge, and here you just see like a few different tools which support that. And I'm sure one or the other you know for sure, right? So from the platforms to the CI/CD tools to the dev tools, and hey, there is even like things like Spring Boot or even Quarkus. So if you do something like in Spring Boot, like mvn spring-boot :build image, if you would use that, it would use Buildpacks under the hood to create a container, right? Quarkus also has an extension. I know Quarkus usually like comes when you create a project with 3 different Docker files, but you could also use Buildpacks for that. So there is an extension for that as well. Then we have like the pack CLI, and there is like many other tools as well. And then also like the container registries, they are also like showing the output in a proper way that you can see like what created this layer, basically. Good. So the idea is, as I said, using a tool to create containers on many different ways, not in many different ways, but in different ways than the Dockerfile, and being also even superior than the Dockerfile. So we'll see later like what I mean by that and like how things could be different. So the Cloud Native Buildpacks, and now we are on the specification level, comes like with 3 different things. It comes now here with the pack tool, it comes with a specification, and it comes with a library for the lifecycle. The lifecycle is used to detect certain things and to go like step by step through different steps to create a container. So these are like the three things which are basically specified, and also tools like Paketo are using. And even like Spring Boot uses the lifecycle from Buildpacks to do the things in the right order. So, why should you use now Buildpacks over Dockerfiles? Who can tell me, if you look at this example, what's wrong about this Dockerfile? What's wrong about it? You're all specialists. Most of you are using Dockerfiles, right? What's wrong about it? So the OpenJDK has not the digest there, for example, right? So you might always get the latest. It's even worse. That's a version which is not even maintained. OpenJDK is not maintained anymore, so you would need something else for your Java distribution, right? So that's another problem, right? So you can download it from Docker Hub, but it's really like vulnerable and they are stuck on certain versions. What else is wrong? Sorry? The copy one should be the last one. Does it really matter? I think adding the other layers are quite fast. You could do it at the second last entry, of course, but I think it does not matter much because the layers which are added afterwards are super small. So yes, but definitely something. But if you think of the copy line, if you're doing a Spring Boot application, you should unpack your fat jar because the Spring Boot application will start faster. So you need to explode the fat jar. This example does not explode the fat jar. And you already have a benefit by having it exploded, unzipped basically, and run it from the jar launcher. What else is wrong? There's even more things wrong. What about the user? Which user is used to run it? It's a privileged user, high likely. So it would be good to have a non-privileged user. And of course, it depends also on the runtime and how it's managed. But if I would run that on my machine, like with Docker Desktop or so, it would use the root user, yes. It's quite bad, right? So, yes. There might be even more things, but you got the idea, right? So there are some flaws in there. I mean, I just copied that from the internet. There's so many things wrong. So, and you need to know that better. So that's why I said also before, I would love to like reduce the cognitive complexity because we don't know all these things and we maybe don't have the energy and the time to know all those things. So if you're now using a CLI tool like this pack tool, there are some commands you could use to like generate anything and put it into a container. So the pack builder suggests, and I just like shortly jump into my command line. Here we go. I hope. No. The pack builder suggests, I can show that here. It's just outputting the things. So I ran that this morning. So you could see like what it suggests, what kind of like builders are there. So what kind of like companies, for example, builders for Google, builders for Heroku. Then we have the Paketo Buildpacks here. They're just like mentioned because they're part of the ecosystem. But they are building slightly things different. And depending on the environment you would deploy, you would use like one over the other. So it suggests you could actually see like what kind of builders are available. And you see also like in the name, we have like builders with Ubuntu Jammy. We have at the bottom like this UB8, so Red Hat UB8 base images actually. On top there is a version from Google, right? So there is a lot of possibilities you can use here. I just jump back to the slide, and what you could do now is, you could now do something like if you are in the application folder, here we go, you could say like, I want to use this builder and find out what kind of container you need to build so that we have a container afterwards. And below you see even examples where you can switch between Ubuntu Jammy to Ubuntu Noble, for example. because like different LTS versions, and you would use a different base image at the end, right? But I'll go into details later. There is another thing. As I said at the beginning, I do quite a lot with Spring Boot applications. If you start your Spring Boot application in a container which is created with Buildpacks, there is like things here at the top, which is just like there too. Let's call it like that. Because what I mean by this is, the things which is happening on the top is basically like from the Buildpacks added. And I know I cannot zoom in actually. It's hard to see, but you can imagine there is something called a memory calculator, which uses the memory which is provided to your pod, to your container, and calculates the heap for that. So if you change or adjust the memory for the pod, when you start the application from scratch, your heap gets freshly calculated, right? So you know like how the distribution for the heap is done. It's detecting, for example, if you have like Spring Webflux in your application, or if you use like the traditional approach, because like the amount of threads would change. You would have like way less in the calculation, way less threads in the calculation for Webflux compared to the traditional approach, where every request is basically served with a Tomcat worker thread. There are other things which are added. You might like it or not, but I think this is quite nice. JVM parameters like exit on out of memory error. So if my application fails, I can just like let the JVM process die, and Kubernetes will restart my pod again automatically. If you want to have a heap dump afterwards, of course, you can add some parameters as well, so that the heap dump on the exit will happen as well, and would write the file somewhere, right? So these kind of things are added automatically just because you use Buildpacks, and I haven't done anything to get this as a starting parameter. And then, of course, there is something also like here. It's saying here which kind of user is used. Just to show you, it's the CNB user, and that means like Cloud Native Buildpack user, of course. So it's not a privileged user at all. It's just like a very specialized user just for running the Java process. So you see there is quite a lot of things which happens behind the scenes and which are quite handy. Good. Let's continue. Now, let's think how you would do this in the enterprise environment if you would write the Dockerfile. Let's assume you want to add certificates to your trust store in Java. So you would use the key tool and you would add your custom CA to your CA certs, right? You can do that this way. And then the question would be like, how would you do that in Go, for example? How would you do that in another programming language? You would also have an approach to do that, of course. But by using Buildpacks, it's way easier, because you add just like a folder where you have your certificates, as you can see here in the example, by creating certain files, like the type file, by adding the mycert certificate, and then while building my container, I'm just like mounting additionally that folder so that actually that certificate can be added to your container. And it doesn't matter for which technology, it's for all the same. So fun fact is, when we look at the bottom where I started the container just to see things, you are recognizing very at the bottom the 147. And compared to the previous one here, we should see 160, 146. So just to prove you that actually like it was really added, right? So that means like you can have your certificate authority from your company, which is self-signed, easily added into your containers just by providing additional parameters. And you don't need to think of like, where do I need to add it? Do I need it to add it to the operating system? Do I need it to add to Java? Do I need it to add somewhere else? Right? It makes my life so much easier. So, and this is actually like the thing. If you do it for Node, for Go, for Python, for Ruby, whatever, it's the same approach. Okay, so what are the basics of Cloud Native Buildpacks? So one screen went away. We'll take the other two. Yes, so what we need to know is there is like a build image and there is a run image. So we do like 2 steps. We are building the thing, which needs maybe more tools, and the run image is just like the thing we need at runtime. So that the base image at runtime, the minimal stack we need in the container. Build packs are actually logic which add certain things to it. So that means like a build pack might add Java into the container. It might add tools to the container. It might add the certificates to the container, and so on and so forth. Build packs are changing actually like the way a container is created over time. It's just doing like a step ahead, next step, and so on. So then the life cycle is the thing which orchestrates the build. So there are different phases we will see in a minute, and it just makes sure that we go through this life cycle. And then there is a thing called a builder, which is kind of like summarizing everything. Good. So now, how does such a build pack, or like how do multiple build packs work? You have your source code, and we want to create a container image. And the build pack has like 2 steps in there. There is a detection phase, where it checks for certain things to do something. And then you have the build phase where the thing is done. So the detection phase is just like the thing where things are checked. And everything is actually like described in a TOML file where you have some meta information and where you also would say like how you depend on other build packs. Because of course you need or you need a specific order for doing things, right? If you think of like your Spring Boot app, you want to like add the jar file, you want to explode the jar file, you want to change the entry point that you run with the jar launcher, and so on. So this is basically like in these 2 steps, detection and build. I can show you an example afterwards because I used the new Java 25 feature where no build packs exist, and I have implemented that, so I can show you that then towards the end. So the detect phase is detecting things, like for Java files or jar files, because if there are Java files or maybe if there is a POM file, it would maybe do a Maven build first, right, to create the thing. If the jar file is already there, it will just like try to run it from the command line, might even like to explode it and run it that way. And you can imagine similar things for the package JSON. The build step is doing the things. As I said, it's really like creating the layer and it's doing the specific things. So the first part is just like detecting things and knowing that the build step needs to do something. So we have this kind of like phases from analyze, detect, restore, because we might have like some layers which are already created and don't need to be created again. We could restore them if they're cached. Then we have like the build phase, and we have the export phase where we create a container at the end. So basically like all the layers get merged, or no, not get merged, but get added together and get exported as a full container at the end. So these are like the 5 steps we will also see later in the logs. Now, as I said before, the builder is basically like a compilation of everything. We will use different build packs to do like different steps. And there is also a thing which is called stack. This terminology is like deprecated right now, but it's still available, but it should go away. But in there, we have something called a run image and the build image, the thing to run the application and the container or the infrastructure to build the thing, right? So those are not going away. It's just like the terminology or like the grouping for those two calling it stack is going away. Okay, so if you now use build packs, why would you customize things? Why would you maybe even like write your own one? Why would you like use build packs at all, right? So that's the question. So think of that. If you have your, let's say, Spring Boot application or your Java application, and you want to customize like your build packs, you could, for example, say, I'm going to use a different Java distribution. So you could use something like Azul Zulu instead of Bells of Liberica. Or you could use just like something else, like Eclipse Temurin, for example. So you could choose different versions of Java builds. So you would say like what kind of build packs you're going to use to add the JDK. We have seen the example regarding the certificates. That would be another thing to like customize it to your needs, maybe even adding some things like information regarding proxies and so on. Also, like if you would like configure different paths for repositories, because like if you do build packs on my machine right now, we will hit like a repository in the internet. You might have like things which are internal, so you have to like point it there, of course, as well. So also customization needed. There is another thing actually, which is, I would say, like rarely used, because when we build applications, we trigger the pipeline, and that step to actually rebase an application is the idea that you have your container and you just change the lowest layer where your operating system parts are in there. So you could say like, my Ubuntu at the bottom has vulnerabilities and I want to rebase that part so I get the new run image there, and I'm not going to rebuild things on the top. So my build is fast, or if I would do that in the pipeline, or I do it manually and push it again, but I do not need to rebuild your application, but you just like change the layer where the operating system parts are in there, right? There are quite a lot of build packs available, so there is a registry with several hundred different things you could use, and you can imagine for many technologies there are also like different solutions out there. And of course, if you use something like Spring Boot or so, there are the build packs which belong kind of like this ecosystem, and you would use those anyway. And it depends really like on your platform where you deploy things and so on. So, Paketo we talked about already, and we said it's an implementation. They are available like in 3 flavors. We have like the base flavor, we have the tiny flavor, and we have the full flavor. In the base flavor, we get like the core build packs for the major languages. So it's kind of like a little bit in the middle, right? The tiny one, there is a tiny one for Java. It has just a minimal tools in there. It would be also nice for Go applications or for native applications, for example. The full one contains like lots of like tools in there, and would be for something which is, using all these things. So you can check this best actually the documentation from Paketo to see where your programming language or your platform fits best. And Paketo has quite a lot of different build packs which support certificates, SBOM generation. Then you have like adding annotations and labels to the containers, as well as ARM64 support. So you can run it on your Mac, or Red Hat UBI compatibility as well. So if you are forced to put it on OpenShift and you're forced to use like a Red Hat UBI image, it's also there. So Paketo just supports that. The interesting thing is like regarding the bills of materials. So there is a step where it just like tries to find out, hey, it's an Ubuntu. We have a package manager. We can see like what's installed there, right? So it would get the information from that. It would also get the information from your Spring Boot application or from your Java applications, because you have jar files in there. And it will create SBOM files. And you could then, for example, in Spring Boot, hit an endpoint and get like the structure back, and you could actually like check which dependencies are running in production. This information is also added to the metadata of the container, so you can easily extract that with the command I put on the first line. So you can extract those files actually as well. But in Spring Boot, you could also expose it via actuator. Then there is like things, how you would configure typically like build packs. It's like using environment variables during the execution of the build packs. So that means like if I would put something like this build pack Datadog enabled, it will add an agent to the container and to the Java process, and it will just install that. And you don't have to do it manually. So because the build pack for this exists already. So you just could say like, I want this, and it gets added. there are quite a lot of these kind of like agents available, and you just use an environment variable to add it. And of course, if you're running it, there is then also like environment variables you would use to like configure where you have your API key, where is your site, where you push your data to, and so on. So it's kind of like both sides, environment variables for building and for running, for configuration purposes. So like the way we do things with containers, of course. In the Java world, we would add a line to the Spring Boot Maven plugin, for example, where we would say like, let's use these build packs and let's just like pick the things, right? And you could customize those. You could use different ones like this one, where I switched to Adoptium. So that's like Eclipse Xamarin. And I just said, I want to use the Java build pack fully, so it tries to detect what's going on there. And many things happen now behind the scenes, like optimizations for Spring Boot, you could enable as well. The memory calculator gets added, as we have seen, and so on. You could also do things like shrinking your JVM by using JLink to create a custom Java inside your container. You could enable JMX support and other things too. And even like building like Graal VM native images would be possible without installing Graal VM on your machine. In the build packs, you would actually like execute the Graal build. So we are getting to the point where I show you some more examples. And that's the thing where I have some more logs created. And please bear with me, I had to run it before because like the Wi-Fi would be so slow here, I assume, or maybe not stable. So I had to do it for you before. And you just can like walk through the logs. And of course, it's faster this way to read through the things as well. So what I did here is, I just like did the command pack build, and I create a container called myapp-google, and I'm using the Google builder, right? So that's the first thing. We now see that different images, Docker containers get pulled, so the builder gets pulled. We have the run image which gets pulled here, and we get also the lifecycle module which gets pulled as well. And you see now it's from buildpacks.io in a specific version. So the lifecycle is related to analyzing, detecting, restoring, building, and if I scroll down, exporting. So that's what we learned before. Now, in the analyzing phase, it just checked that my app Google does not exist, right? So we need to build it. Then actually, like it found out, we have different build packs which could be used. It's a Java application, it's a Maven application. So we get the Java runtime, we get Maven added, an entry point needs to be added, and they add also some labels, right? And this is basically like what happens in the next steps. And it also realizes that certain things are not cached at all, so things need to be downloaded. So in the building phase, so a build pack would now install Java. Below, you see the exporting phase where layers get added to the run image, and in the end, like the whole container gets exported. Okay, so I'm switching to the next example. I used now not the Google builder, but I used the Paketo builder with Noble in the small version. And here you also see like, oh, the container was not up to date, it was just recently updated, so it had to pull things. And then you see, oh, there are like 26 build packs, and 10 were detected which are possible for this Java application, okay? Strange things, Apache Tomcat, Apache Tommy E, Liberty, probably we don't need them. It's like a fat jar, so yeah, but they will find out later. But they just detected those things. Now actually, when you look at the steps, the first part is about adding certificates. Then you see like the configuration regarding the Java version which is installed. It's the build pack version, it's not the Java version. And you will see below that it's downloading the JDK for doing the build and the GRE as well for the run image. So we scroll down a little bit and you will see things, for example, like regarding the SBOM generation. So SIFT is installed. You see the Maven build, because it recognized the POM file, so it would run the Maven build. Then it has a fetch jar. So it sees like there is a manifest which points to the jar launcher. And then actually like the build packs for Spring get triggered too. And you see here some optimization regarding AppCDS, AOT could be configured too. We didn't do anything. The only thing what it does is it's adding Spring Cloud bindings, which means like liveness and readiness probes get automatically detected when you deploy the application on a cloud platform. And then we are exporting the things here. Another thing I wanted to show you is, I did this now on a Spring Boot application. You see on top, MVN Spring Boot build image. I didn't want to run the test because it would pollute the log quite a bit, right? So I didn't do that. And we just scroll down, and there is a certain step where it tries to download again, like my build pack builder, and then also like the Java build pack. And here now you see something which is different from before because it's for Spring Boot optimized. And what you see is now 7 out of 27 build packs get detected. Why 27? It was 26 before. Yes, the last one here is the one I added. That's why it's 27. It would always be 26, but mine got added too. So I do something special there. So it tries to restore things, and it could actually like restore a few things because I did the build before. You see like the same step as before regarding Java, right? Regarding Sift, regarding the executable jar, regarding the Spring Boot part. But what happens afterwards is, here, I do my own one. I run a feature on Java 25, which is called AOT caching. And I do a training run for AOT caching, which means like I start Spring Boot, I dump the class files which were loaded, so I can restore from there, instead of like restoring again from the jar files and class files. I restore from a from an archive. So, and that happens here, the training run happens, it starts my application, it stops it afterwards. You see also like some really strange things regarding proxies and Hibernate and so on, because like these classes are loaded and they're like registered, right? They're now locked. There's something going on, something special, this AOT caching. And then it also adds additional parameters for the JVM run. So like this AOT cache output. And I say like the archive is done there. So the archive is actually like this app AOT file, right? So when you are through with the whole step, so it did some more things here, then actually like it's exporting this again. Now just to shortly show you, I added now these additional steps, my build pack, my own build pack with a detect phase. That's a script which is going to check a few things with environment variables. It's creating a build plan, so it's adding that one after the Java build pack. And then actually like what's important for us to understand is we are running the Java process, which now for the training run is basically like this part here where we are going to create this AOT or this app.aot file. And this one gets added additionally to the container, and that's it. So yes, I need to like wrap things up. So I have some challenges and some solutions to that. Sometimes you have like some special requests from marketing because they want to have custom fonts in the container, right? So you could do that. You could add them via build pack to your container, or you just patch the base image or the run image. And the run image can be derived from a Dockerfile. So you could install it as I did it here, just via apt-get and install the additional font. And of course, I mean, sometimes I have like special requirements like emoji fonts because you need them in a PDF or so, right? Who has these requirements? They're usually just like waste in a container, so that's why they are not there. So I had to add it. Then actually, like you might want to do other things like metrics, maybe checking for licenses during the build or logging configuration, and many other topics. So that's why you would create your own build packs, which you could register. And in Spring Boot, actually, you could add builders and build packs just in your Maven configuration, and it's that simple. And you see, I added my own one because I wanted to have like a different Ubuntu there, for example, or maybe like the version I patched myself with the emoji font, right? And if you want to change Java, you have that many options. I just commented out all the ones I know, so you could like switch for a particular one, right? You could say like, I want to have Oracle Java in there, or I want to use SAP Machine or something else. Or if you want to optimize your JVM, you could shrink it just for the modules you need really in your application. I could strip out all the other modules. And that's like how I would do that with some environment variables, right? And then you do something like AOT and AppCDS, which is also like this Java 25 features is AOT caching. It's very similar to that, but it's already available in 21. You could also just configure that instead of like writing your own build pack because it's already there. So you see, you can customize quite a few things. And of course, I believe those things actually like belong into the pipeline because it takes a little bit of time. And yes, you are anyway not building containers on your machine, right? And by adding things to the pipeline, you can also make sure that all your apps get added agents or like, let's say, license checks or CVE checks and so on. Okay, so that was my presentation. I just wanted to give you a few takeaways. I wanted to tell you, hey, you don't need Dockerfiles at all. You can really like focus on your domain. Let the people who know how to do like the containers the right way, let them do it for you. Because build packs usually they always follow like best practices, the ones at least we get from the build packs community. They're even composable. Think of that you have like a Java build pack and a build pack for the front-end part. You can combine it. You can build your Spring Boot application with Angular, for example, in the same container creation. You can make sure that different kinds of apps with different technologies can use the same set of build packs regarding certificates, for example. You only need to rebuild layers which really have changed, not the ones from there where it has changed like upwards, right? Like you would have in Dockerfiles. And of course, we know that they're also reproducible. And then on the other hand, if you have the need just like to change the operating system layer, you can easily do that with this rebase command, and you just would switch the container and you would relink the layers again, and you would push the new container and you would have fixed it without building your application. Cool. So you saw build packs make life much easier. They reduce cognitive complexity a lot. Of course, sometimes it might feel like a little bit of magic, but if you get into it, you just see like how much easier it is, and depending on your needs in your application, let's say like you're just building CRUD applications, it's so much easier than actually like using Dockerfiles. Great. That was my presentation, and I don't want to stop you from the break. If you want to talk to me, you can do it in the break or also afterwards at the apero. Thank you very much. And if you want to see some examples and the slides, you will find them in my GitHub repository, and you just can browse through and you will see like several examples there, how I did some things, even like my own builders, my own run and base images, and also like the AOT example. Great.